So in the dihybrid cross, we have two separate traits. We want to show that those traits undergo independent assortment, one of Mendel's principles, meaning that how one trait is inherited does not affect how the other trait is inherited. What I've shown right now is a key, meaning the genotypes and phenotypes for each trait. Both of these traits show the pattern of complete dominance, meaning that if there is one dominant allele, the plant shows the homozygous phenotype. To solve this problem, you want to start with a key, show your understanding of that pattern, and then we're going to go ahead and show the cross. In this case, we're going to do a cross with heterozygous parents, heterozygous for both traits. So the parents are going to be big T, big R, little r. Big T, big R, little r. So to make a dihybrid cross, you need to have a 4x4 Punnett square. The easiest way to make a 4x4 Punnett square is to start with a large square, to first divide it into a 2x2 square, and then to divide that in half both vertically and horizontally. And then you get a nice, neat 4x4 square. Okay, the next step is to determine what alleles each of these parents can put into their gametes. And to do that, the easiest way is to use the FOIL method, as is sometimes used in math. So FOIL stands for first, outside, inside, last. In this case, the first, outside, inside, last refers to these two pairs of alleles. So the first of each pair, the outside alleles, the inside alleles, and the last alleles in each pair. So for example, for this parent here, the first alleles are going to be big T, big R. Outside, big T, little r. Inside, little t, big R. And last, little t, little r. Okay, to do this parent, same thing. First, big T, big R. Outside, big T, little r. Inside, little t, big R. And last, little t, little r. Okay, when it comes time to fill in the offspring for the squares, again, you're going to follow those two rules. So remember, you're always going to make sure that you keep alleles of the same trait together. So you're going to keep your T's together and your R's together. You're also going to make sure that if there are two alleles of that type and there's a dominant and a recessive, that you always put the dominant allele first. So in other words, you would put the big R before the little r. So to fill the square in, you're going to simply follow those two rules and combine the alleles to make the genotypes of the offspring. Okay, and when you do this for a while, you can get pretty fast, but you're going to make sure that you are accurate. Okay, pausing here because I want to make sure that I get the big T before the little t. And if you solve the problem this way and set it up this way, what you'll see is that some very nice patterns emerge. You're going to end up with the most dominant set of combinations in the upper left and sort of working its way down to the most recessive set of combinations in the lower right. And that's going to make it much easier for you to show the last step of the problem, which is to do an analysis of the genotypes and the phenotypes. So when you do an analysis of the genotypes and the phenotypes, what you want to do is keep track and mark off each possibility as you do it. For a dihybrid cross, it's much easier to use fractions than it is to use percent. So I'm going to start up here with the possible genotypes. Again, I'm going to start in the upper left and work my way down to the lower right, and that's going to make it easier for me. So upper left, I've got the most dominant possible combination, big T, big R, big R. And there are going to be just 1 out of 16 of those. I can work my way down and to the right and see that there are 2 possible combinations out of 16 of big T, and big R, little r. 1 possible combination of big T, little r. I'm going to work my way out here to see that there are 2 combinations of big T, and big R. And then I get a nice pattern here all the way across diagonally. 4/16, big T, big R, little r. Again, continuing to work down and to the right. Let's go ahead and do these 2 next. I'm going to have 2/16, big T, little r, 1/16, little t, big R. 2/16 of little t, big R, little r.